Waste disposal is indispensable as social infrastructure. In today's society, environmental issues must be discussed on a global scale. In Japan, too, we have continued to sacrifice something valuable while we achieved rapid economic growth during the post-war period. Industrial wastewater flowing into Osaka Bay polluted the sea, causing tremendous damage to fisheries. Under these circumstances, Tadaki Tanaka, an Osaka Bay fisherman, established Kinki Environmental Industry Company Limited, the predecessor of REMATEC in 1974. After he engaged in collecting and transporting waste, he built a system to collect waste oil discharged from factories and recycle it into fuel. He took the lead in promoting a recycling-oriented society. Since then, while responding to the changes of the times and the characteristics of local communities, REMATEC has worked to solve numerous environmental problems with innovative ideas and steady efforts. In April 2014, 40 years after the foundation of Kinki Environmental Industry Company Limited, we shifted to a holding company system and took a new step forward as the REMATEC Group. Our goal is to contribute to the establishment of a sustainable society by utilizing REMATEC Group's technology to recycle various materials. Based on this guiding management philosophy with both the Japanese and global markets in mind, we use our group's power to continue contributing to protecting the global environment. We will introduce our RF business, a resource recycling system using an industrial waste recycling plant. As of April 2014, the remaining capacity of industrial waste final disposal sites in Japan was approximately 183 million cubic meters. Estimates by the Ministry of the Environment indicate that these sites will become full in about 14 years. Thus, the waste disposal environment continues to face difficulties. Under these circumstances, in addition to reducing waste disposal costs as part of its efforts to increase profitability, industry is urged to fulfill many responsibilities as an emitter of waste. To solve this problem in industry and society as a whole, as exemplified by the 3 R's, reduce, reuse, and recycle, we need to adopt waste disposal methods that better take the needs of the environment into consideration. One of such methods is the REMATEC Group's RF manufacturing technology. RF stands for Reclaimed Fuel, Coal Fuel Alternatives. RF is a reversibly thixotropic auxiliary fuel composite for cement burning, the patented mixing technology independently invented by the REMATEC Group. We call it reclaimed fuel. In other words, recycled fuel using industrial waste. The most important characteristic of RF is thixotropy. Thixotropy refers to a phenomenon whereby material viscosity falls when churned or rises when left standing. For example, products such as mayonnaise and ketchup have such properties. Due to this property, RF exceeds in storage stability and can be safely transported as its viscosity falls when pumped. Industrial waste recycling plants utilizing RF manufacturing technology can recycle a wide range of industrial waste from liquids such as waste oil, waste acids, and waste alkali to sludge and powdered materials such as cinder, discharged by various industries such as oil refiners and chemical manufacturers, ironworks, and paper mills. Using unique know-how, plants mix and knead various types of waste, adjust calorific value, chlorine levels, viscosity, and so forth, and then recycles waste into auxiliary burning fuel for cement factories. In addition, the RF manufacturing process does not generate exhaust gas as it is performed at normal temperatures and pressure levels. The waste received is mixed using REMATEC's proprietary mixing technology, nearly all recycled into RF. Thus, this manufacturing process generates no wastewater, a major cause of environmental pollution. Approximately 98% of waste put into the process is converted into RF, and all cinder generated at cement factories after combustion is used as raw material for cement, so no final disposal is needed. In short, RF production is an environmentally friendly recycling system with zero combustion, zero wastewater, and zero landfill. The RF manufacturing process from reception to mixing to shipment is as shown here. It is important to grasp the properties and conditions of each type of waste. The know-how for matching various types of waste is also important. Now we will explain the RF manufacturing process in detail. The RF manufacturing plant receives waste using the optimal method for each type of waste. When received, all waste liquids are sampled to analyze their properties and conditions. After safety is confirmed through comparison with contracts and mixing tests, waste is put into different tanks for storage, depending on the contents and the type of waste. Waste drums are also similarly sorted and stored after 100% inspections and mixing tests, and put into dissolvers for storage using drum tumblers. Equipment dedicated to neutralization of strongly acidic or alkaline waste liquids are also installed. These liquids are neutralized in advance to reduce mixture risks. Waste sludge is put into the sludge tank and powdered waste material into the powdered material pit. Both are analyzed and stored according to the type of waste. Various types of waste are mixed according to the rate of combination determined in the control room. Waste liquids are sent to the primary mixer after weight is automatically measured in the measurement tank. Powdered waste material is put into the primary mixer using the crane and flight conveyor and mixed with waste liquids for churning. Then the secondary mixer churns the mixed liquids at high speed and powdered material to crush solid matter. Through these processes, the waste becomes thixotropic and is converted into RF, recycled fuel. Characteristically, RF is made easy to transport, store, and use through thixotropy. Specifically, while its viscosity rises when it is stored in the tank, preventing oil and water from separating, the viscosity falls when it is transported via pipe or during spray combustion, becoming liquefied. Foreign substances are separated from the completed RF using a vibratory screen to enhance quality. In the last shipment process, products are analyzed for each shipment lot and only RF that meet company standards are shipped. To ensure safer operation, the RF manufacturing plant devises measures to reduce waste mixture risks causing adverse chemical reactions. The plant classifies the causes of chemical reactions and accidents attributed to them, etc., into 5 categories: those related to equipment, those related to material, those related to human skills, experience, and knowledge, those related to information such as documents and manuals, and those related to organizations such as management and administration. Then it analyzes the classified causes and devises the safety measures it should take. Basically, when this plant was built, it was designed as a chemical plant meeting the guidelines for chemical plant safety assessments issued by the former Ministry of Labor. RF does not fall into the category of hazardous materials as defined in the Fire Service Act, but in order to ensure its strict control, the plant has been authorized as a manufacturing site of hazardous materials. The factory is divided into 3 buildings with tank yards installed at 2 different outdoor locations. In addition, as part of the deodorization measures, exhaust gas from the vent of the tanks is collected using deodorizing equipment. Waste acids and waste alkali are treated by neutralizing them in advance using dedicated equipment. Thus, pH levels are constantly controlled to minimize mixture risks. Nitrogen generators are installed on the assumption that combustible gas remains in the waste oil and other storage tanks. The tanks are filled or empty using breather valves, and empty space in tanks is always filled with nitrogen to prevent combustion or explosion. In addition, the plant has equipment that sprays cold water if storage tank temperature rises rapidly due to factors such as heat from chemical reactions. In addition to spraying cold water on tanks, this equipment injects cold water directly into tanks as circumstances require. Furthermore, there is a device that releases storage tank pressure. If the pressure level rises sharply, it automatically opens valves. And the plant is structured so that if chemical reactions produce hydrogen gas detectors and roof fans installed on the ceiling of the building automatically release the gas outdoors. In addition, a system has been put into place to automatically measure the temperature in each tank, detect changes taking place, and swiftly respond to those changes. The plant also makes hydrogen concentrations visible by establishing maximum permissible in-plant hydrogen concentration control levels and monitoring hydrogen concentration levels. If hydrogen concentration exceeds the control level, alarms for swift action sound in plant buildings. As part of the measures to properly grasp the properties and conditions of waste, we have strengthened the inspection system for waste brought into the plant. To confirm the chemical properties of waste, we take samples and analyze them to determine whether they contain heavy metals or such. We make an all-out effort to confirm the safety of waste in advance by including risk details based on chemical knowledge in the sample examination documents. We conduct 100% inspection of all waste materials contained in drums. When received, all waste is compared to the properties and conditions described in the contracts to confirm any differences. In the case of mixed waste, we conduct mixture tests using beakers to confirm the mixture composition or any chemical reactions. We ask dischargers to provide detailed information on the waste they discharge using documents such as waste data sheets and safety data sheets. We use these sheets to determine in advance whether we should accept waste from dischargers. We also ask dischargers to provide information on changes in the waste generation process or the chemicals used, etc., periodically confirming that there are no changes from the waste properties and conditions described in the contracts. Furthermore, we have created calorimeters, chlorine analyzers, fluorescence X-ray analyzers, flash testers, pH meters, and viscometers to establish a high-level analytical system. As part of employee training, we hold meetings of all employees to examine operation flows in accordance with safety assessment guidelines. Other training programs include training aimed at improving knowledge of chemistry, tests for degree of understanding, and follow-up training based on test results. We also ask the Japan Industrial Safety and Health Association and other external organizations to send experts to training sessions mainly for managers and supervisors. Lecture subjects include fires and explosions caused by chemical substances. One information-related initiative is establishing work standards for each factory. In addition to periodically revising work standards as required, we certify the abilities of each employee based on work standards and other guidelines in an effort to improve skill levels. To reduce waste mixture risks, the Kyushu plant operates 24 hours a day. We receive waste and produce products at different times. After the properties and conditions of received waste are made uniform in storage tanks, we take samples from each tank to determine the mixture of products to produce on the day. We also established a production technology department staffed with personnel possessing high levels of chemical knowledge. Thus, we have strengthened the system for assessing waste mixture risks based on chemical knowledge, ensure quality control, and improved employee skills. By properly controlling risks, we will continue to strive to ensure safe operations of the RF business and improve the quality of the products we produce. We will also work to become Japan's safest waste recycling plant. In the future, we will establish a system for proposing new, more environmentally conscious ways of recycling. REMATEC's RF manufacturing technology mixes various types of waste using proprietary know-how to convert waste into fuel alternatives to coal. At the REMATEC Group, two companies, REMATEC Corporation and REMATEC Kyushu Corporation, produce approximately 110,000 tons of RF annually and sell it to cement factories as auxiliary fuel for cement burning. By recycling waste into coal fuel replacements, we help reduce greenhouse gas emissions. This recycling system, based on RF production, enables us to produce products that suit the waste we receive. Our founder hoped to restore the ocean's beauty. REMATEC's unique resource recycling technology has recycled a wide range of industrial waste to protect the natural environment and conserve limited resources. We at the REMATEC Group will contribute to creating sustainable innovations and developing local communities.